Okay guys, we're going to be doing Unit 8, Day 1 today. So we're going to look, the first thing we're going to do is look at these two graphs. It says to match the situation to its corresponding graph. So we have graph B and graph C here. So we're just going to identify our line. So we have in graph B, our line is up and to the right. So that's determining that we have a positive slope in this graph. And if you're looking at graph C, you have the opposite where the line is pointing down and to the right. So that's a negative slope. So if you look at 1 and 2, it's asking us with the information given, what graph would we use? So in 1, the noise level of traffic decreases after the evening rush hour. So that means we're going to start high and go down. So our answer would be graph C for number 1. 2 says a helium balloon is released into the air. So if we have a balloon, it's floating, the height is going to be increasing. So our height will be going up. So we're going to look in that graph that matches that is graph B. So let's read through number 3 and identify the important pieces of information in there. It says a plumber charges $100 plus $50 per hour to fix something in the house. Write an equation, create a table, and draw the graph to model this equation. And then we're going to solve for how much it'll cost after 3 hours. So I underlined our 100. That's our flat fee. So we'll identify that in our equation. So we'll always be paying $100. So that's the flat fee. And then we see our keyword per, which is always used when we are identifying our slope. So the keyword per is attached to 50. So we are going to have our equation, which is y equals 50x plus 100. So that's going to be our slope there. So we wrote out our equation. Now let's do our table here. So we're going to do our hours are going to be represented by x, because that's what we're solving for here. And then our cost will be y. So let's just start out with what we know. We're starting at 0 hours, and we have our flat rate of $100. So if we're going to go up by an hour each time, let's say we go up to 3 hours, we're going to be plugging in our x value in for the 50. So 0 would be 100. If we're plugging in 1 here, we're going to get 150. We plug in 2 for our x, we're going to get 200, excuse me. And then if we plug in 3 for our x, we'll get 250. So notice the relationship between the y's. It's increasing by 50 each time. So that's another way to just double check and make sure your slope is correct. So the last thing that we need to do is graph our equation here. So we'll label our 2 axes with our cost, which is going to be in dollars, and our hours down here. So all you need to do is take the 4 points that we have here and plot them on the graph here. So we'll start with our x, which is 0, and the cost is 100. And we're just going to go up by 50 each hour, and we will end at 3 hours. So I'll grab my straight edge and just make a straight line there. And that's our graph right there. So we'll go back and just read the equation, and it says how much will it cost if he's there for 3 hours. So we're going to look back at our table here, and we determined that it was $250 because we plugged in 3 for our x. So just to remind you guys, 5 times 3 plus 100. So that's going to give us 150 plus 100, so that would give us 250. So it would be $250 would be our cost. So if you guys missed anything, go ahead, pause the video and review what we just did. Otherwise, go ahead and flip over and we'll do the back side there. So number 4 is very similar to what we just did on number 3. It says Janet is rowing across an 80-meter river, and her information is listed in the table. Find the equation of the distance that she has remaining before she reaches the other side. So we have our time over here, and we have our distance. So let's look at what we know about our slope. It doesn't give us a direct slope here, so what we're going to do is figure out the distance between our meters and the difference as we go down. So from 80 to 77, we're going down 3. From 77 to 74, we're going down 3. From 74 to 71, we're going down 3 as well. So that means our slope is negative 3. So in our equation, we will have y equals negative 3, and remember, we're going to attach that to the x, plus 80. Remember, we got our 80, that's our starting distance there, our distance from our shore. So we have our y equals mx plus b over here. Our y-intercept is right here. So it's asking how long until she reaches the shore. So we are going to plug in 0 for our y here, and we're going to solve for our x. So we'll do 0 equals negative 3x plus 80. So we're going to solve for our x, subtracting 80 from, or actually let's add 3x to both sides. So we have 3x equals 80. So we'll divide both sides by 3. So x equals about 26.6. That's going to continue on. So we'll say it'll take about 26.6 seconds until she reaches the shore. And 5 and 6 are our last two problems on this. All of this information on the left is for 5. All of this information on the right is for 6. So it's asking us to evaluate the piecewise function for these two values of x. So what you're going to do is look at the value of x that's given to you and determine which statement is true and then plug in that value. So looking at A, x equals negative 2. So we are going to look at the two statements on the right here. It says x is less than or equal to 1. So is negative 2 less than or equal to 1? The answer is yes. So we're going to plug that in. So we're going to choose to use x is less than or equal to 1. So you're going to take that value and plug it in. So negative 2 is going to go right in here. So x plus 2 is the equation we're going to use. So we'll put in a negative 2 plus 2, and our final answer would be 0. So we'll do the same thing for B as well. So our x value is 5. So we read our two statements again. Is x less than or equal to 1? The answer is no. So is x greater than 1? The answer for that one would be yes. So if x is greater than 1, we don't actually have an equation that we need to use. We just have our solution right there. So our answer would be 3. So same thing on 6 as well. This time we have 3 options. So our x value for A is 4. So we're going to read through these 3 statements to figure out which one is correct. So go ahead, pause the video and figure out which one is true. Is it x is less than or equal to 0? Or 0 is less than x is less than or equal to 4? Or x is greater than 4? So the answer is the second one right here. 0 is less than x is less than or equal to 4. So you're going to take what's to the left of that, the 2x squared, and plug in 4 for that. So 2x squared is going to be 2, and we're going to put our 4 in here. Put your parentheses around there so you can raise that to the second power. So we'll do 4 squared, which is 16, times 2. So our final answer comes out to 32. Same thing again with B. Pause the video, figure out which equation it fits into. You're looking at these 3 on the right. Negative 3, which statement is true? The answer is the first. Negative 3 is less than or equal to 0. So we're going to take 3x minus 1, and we'll plug in our negative 3 there. So 3 times negative 3 minus 1, so that becomes negative 9 minus 1. So our final answer is negative 10.